Hi, everyone. Welcome back to Real Estate Redefined, a web series brought to you by Cisco's Hybrid Work Center of Excellence team. My name is Murray, and I'm joined by my colleagues Ansar and Ryan in delivering this episode to you today. In our third episode of the web series, we will be discussing the concepts around energy networking. As a recap of the previous episodes, in our first episode, we broke down the concepts of delivering a smart building. In our second episode, we expanded on the aspects and considerations taken in deploying a converged network architecture. For those returning visitors, thank you so much for continuing to watch and learn from our web series. We hope these episodes are helping you and your colleagues understand what is possible with technology and what the future may hold for the built space. For those who are just joining us for the first time today, please make sure to check out our YouTube to watch the previous episodes in the series. Now let's jump in to episode 3. In today's episode, we are going to be discussing energy networking. To break this down further, our team will be discussing convergence of power and Ethernet cabling via PoE, the potential that 90-watt UPoE Plus has in the built space, sustainable infrastructure, and we'll show you a demo of the PoE analytics available from Catalyst Center, previously DNA Center. Ansar, why don't you tell us about the evolution and convergence of enterprise technology?
Thank you, Murray. The world of enterprise technology is constantly evolving. Companies have to keep up, be innovative, and succeed in a fast-paced environment. Over the past 2 decades, we have seen a big shift in how organizations communicate, collaborate, and run their operations. This change is powered by progress in data, voice, video, power, sensors, and how they all converge with Ethernet. Let us take a moment to explore 3 distinct phases of transformation that happened, and each of it characterized by significant technological convergence. The early 2000s brought major changes to the enterprise communications. Voice over IP technology emerged as a game changer, replacing the old-fashioned analog phones with the digital networks. Where Cisco, a leader in this technology, was at the forefront of combining voice and the data networks. This change allowed businesses to make communications more efficient, save money, and improve overall collaboration. In the 2010s, more people started working remotely, and it was further accelerated by the COVID-19 pandemic, forcing organizations to adapt to a remote-first environment. Consequently, the convergence of the data, voice, and the video technologies became highly crucial for facilitating remote communications. And it helped teams work together even when they were apart, making sure businesses could keep up going during lockdowns and social distancing. As we come out of the pandemic, we are entering a new era, the hybrid work setup. Now, businesses are shifting from completely remote setup to a mix of in-office and remote work. So the need for the technologies that smoothly connect physical and the digital space is more crucial than ever before. This hybrid work model needs solutions that go beyond regular voice and the video communications. They should also include sensor data, power management, and smart workspace analytics. Power over Ethernet, PoE, is a great groundbreaking technology that transmits both the data and power through a single Ethernet cable. PoE plays a crucial role in transforming a modern hybrid workspace by powering a range of devices such as like IoT sensors, lights, window shades, work desk, and more in a building management system. Cisco's UPoE Plus solutions, that's our main topic, takes PoE further by delivering up to 90 watts of power per switchboard. Using devices powered by Cisco UPoE Plus capable switches helps organizations save on energy cost, promote sustainability, and gain deeper insight into workspace analytics. Before we delve into how UPoE Plus solutions unlock new possibilities in a modern workspace, let us briefly look at the evolution of 90 watts PoE. PoE standards have undergone significant development in recent years. At first, we had standards like IEEE 802.3AF and 802.3AT, which could provide 15 watts and 30 watts of power respectively. Cisco then introduced UPoE in 2011, giving up to 60 watts through a regular Ethernet cable, and the equivalent IEEE standard for this is 802.3BT Type 3. In 2018, there was a new standard, 802.3BT Type 4, which increased the power to 90 watts. Cisco added this capability to Catalyst 9000 family switches like 9300 and 9400 series, allowing each port to have up to 90 watts. This improvement meant we could connect and power more devices in a building without using high voltage electrical circuits. I'm inviting my colleague Ryan Casey to further discuss this topic, including how we have overcome various challenges with the high voltage by using the PoE, and what are the benefits of using the PoE in a modern workspace environment.
Thank you, Ansar. So let's go ahead and take a look at the IEEE standard from beginning to where we are today. So if we look on the left-hand side, the evolution and the start of where this actually started was on our Class 1 devices. So this originally was started by Cisco to power phones, as you would normally see on a lot of your desks and your office spaces. So looking at our power sourcing equipment, so our switching gear being able to provide 4 watts on a Class 1 device. And at the end, that device actually consuming a little under that 4 watts. And as we move up into where we are today on Class 8, we're delivering 90 watts based on the IEEE standard to each of the devices that are contained on those actual Ethernet ports. So a little bit deeper dive, if you look down below, we go ahead and we'll look with PoE and PoE Plus on the Class 1, Class 2 side of things. We were delivering 30 watts over 2 pairs that were actually contained in the 4 twisted pairs that are contained in the category cable. And then moving up into the UPoE, which is our 60 watt, our Class 6, we're looking at delivering 30 watts over each of the 2 pairs. So really using the 4 pairs to deliver power over those twisted pairs to those edge devices. And then now with UPoE Plus, the 802.3BT standard, we're looking at delivering 45 watts over each of those 2 pairs, so 90 watts in total. And then that powered device at the endpoint being able to consume up to 71.3 watts based on the IEEE standard. So if you look at the evolution of PoE over time, we're really looking at going from 4 watts to where we are today at 90 watts. So highly more efficient, highly more scalable to be able to provide those new solutions out to each of those edge devices. So building upon where we are today in the IEEE standard, 90 watts is really unlocking new use cases and new outcomes inside a smart building. Whether it be on a Catalyst 9300 or 9400 series, being able to have high density 90 watt deployments, being able to power solutions that traditionally would be powered via line voltage. We're looking at our PoE lighting fixtures, so being able to daisy chain multiple lighting fixtures on a single category cable and be able to provide that IEEE standard out to those field devices. So looking at a highly scalable solution in terms of fixtures, so being able to string multiple fixtures together, and not only that, being able to look at what each of those fixtures is actually using in terms of energy and the status of those devices. Moving to PoE blinds, same concept, being able to string multiple blinds together on the envelope of the building, being able to reduce all of that conduit and that line voltage that would be associated with those solutions, and then really being able to provide that highly scalable and agile solution on the envelope of the building. We have a hard adjustable desks, so we're looking at 2 category cables in our Atlanta office, being able to power a charging station for our laptop, a WebEx desk that's on there, the desk itself, and then also a task lamp. So really looking at a very sustainable and agile solution in terms of powering those particular desks. If we were to look at that on a line voltage side, we would be looking at bringing out line voltage to there and an additional cost. We looked at our cost savings going this approach. For 102 of these desks, we saved almost $400,000 on that install for being able to moving those solutions to low voltage. And then really looking at our typical IT deployments, so our CCTV, our displays that we might have throughout the floor plate, and really looking at converging all of those solutions, being able to provide that in a single switch stack or multiple switch stacks, all back in an IDF. So creating that highly scalable, agile solution and reducing all the embodied carbon that would traditionally be delivered in a line voltage solution.
Thank you, Ryan, for the high-level overview of use cases for 90-watt UPoE+. Looking at the lighting use case in more depth, what are the main components? The first one to call out is one we will see in pretty much every 90-watt deployment, and that is Catalyst 9K infrastructure at the access layer to provide power to the devices. On the outbound side of the switch, there are a couple of ways that different third-party partners have built their system infrastructure, but all have network device that is negotiating for the required power from the switch. Looking specifically at the Molex coursing platform, the network device is referred to as a PoE gateway. From the gateway, different types of devices are daisy-chained using a 4-pin cable including drivers, sensors, and interfaces to connect other controls. The devices on the outbound side of the gateway will each be individually controlled and show as their own data point in the Cisco Spaces platform, where all data connected to the environment is being aggregated. Looking back to the network infrastructure, the access layer will typically be connected to a converged IT/OT distribution layer, and then this connects to the on-site compute necessary to host the software for control of the lighting system. This same distribution layer will also connect to routers that eventually path to Cisco's different network and space management systems such as ICE, Catalyst Center, and Cisco Spaces. Now looking at the topology for PoE-powered window shades, we see almost the exact same network infrastructure to the lighting systems, besides some slightly different specification requirements for the virtual machine hosting the control platform. The network device within the Meko Shade system is also very similar to the Molex CoreSync deployment for lighting. The Meko PoE hub has the ability to connect 2 of their DC shade motors, which in our Cisco offices are moving 6 window bands of shading. The motors also act as receivers on the 902 MHz band for the wireless daylight sensors in the window pocket, as well as local wall switch control for the Meko SolarTrack system. Ansar, why don't you share some details on the PoE-powered desk solution in our Atlanta office?
Thank you, Murray. In today's dynamic workplaces, the traditional work desk with a combination of high voltage power outlets and Ethernet cables are becoming increasingly outdated. To address the evolving needs of modern employees, Cisco has introduced its UPoE plus 90 watts capable switches, enabling the seamless integration of PoE technology even into an office furniture. One prime example of this integration is the PoE-powered electric height adjustable desk. And this innovative desk eliminates the need for separate power outlets, relying solely on 90 watts power delivered through a Cisco Catalyst 9000 series UPoE plus capable switches. Providing spaces for people to focus on work or passively participate in a remote meeting is crucial in a hybrid work environment, and the hot desk is the perfect space for these activities. Our Atlanta office is equipped with 100 plus of this hot desk, all featuring height adjustable electric desk and fully PoE powered. So we do not run any high voltage AC circuits, or we do not have any AC outlets at this desk. What we run is 2 low voltage category Ethernet cables to every desk, each cable supplying 90 watts that is provided from a Cisco Catalyst 9300 UPoE plus capable switch sitting in the network closet. One cable powers a Cisco desk device, while the other cable powers the desk itself, including its integrated lighting and a USB dongle, A USB dongle further provides a USB-A and a USB-C port for charging laptops and other commonly used devices by the employees at their desk. And the distribution of this 90 watts power from a single Ethernet cable to multiple endpoints is actually achieved using a PoE splitter that is fitted underneath the desk. PoE-enabled desk is highly customizable, and its configurations can be easily adjusted to meet the specific needs of any organizations. For example, we are currently assessing another use case to power a mini computer and up to 4 monitors over a 90 watts port using the solutions provided by Thin Labs.
Thank you, Ansar, for the explanation of the PoE desk solution. Looking at Cisco as a company, the concepts around energy networking that we are talking to fit great in our overarching sustainability story. Sustainability is a major focus for many major corporations, including Cisco. When looking at buildings, there are 3 main categories we are going to look into today. First, making the building energy efficient and reducing embodied carbon within the build, primarily by the use of PoE technology. Second, converging siloed networks to simplify the design and operation of the building. And lastly, enabling flexible workspaces through use of gathering of utilization information to allow insights that can help employees focus more on their work and less on where they are going to do it. Ryan, can you talk to PoE technology and the transformation happening in the build space?
So if we really look at transforming infrastructure with power over Ethernet, we're really looking at reducing all of the cabling and all of the actual infrastructure that would be associated with these solutions and collapsing that back on that low voltage DC infrastructure. If you look on the left-hand side, we have a typical deployment for, let's say, a single zone on a line voltage side. And you can look at the actual solution. So we're looking at conduit going out to each of these endpoints. We're looking at ballast. We're looking at transformers and all of the line voltage solutions that would be associated with that. So multiple cable types, multiple different types of conduit sizes to be able to house all of the infrastructure to deliver the lighting for that particular infrastructure. If we look on the DC side, so our power over Ethernet solution, we're looking at a single cable type. So we're looking at a category cable being able to run all the infrastructure that would be associated with this. So our sensors, our drivers that are associated with the fixtures, our PoE gateway, and really collapsing all of that infrastructure, leveraging a single cable type, and then also being able to reduce all of those embodied carbons that would be associated with that solution. So looking at much more efficient, much more sustainable. And then not only that, we're looking at the power delivery method. So we're not having to change AC to DC and do multiple conversion types as the line goes out and then step downs between each of the particular solutions. We're looking at having that power that is power over Ethernet coming out from our switch, and then we have a uniform power distribution throughout that entire floor plate. If we look at a traditional line voltage approach, the inherent solution is very inefficient. So we're taking in your street power into a facility, whether it be a campus, commercial high-rise, manufacturing facility. These are all typical as they come in. And then being able to have the requirement to be able to convert these as for each of the solutions. So if we look at just some of the typical installations you might see in a facility would be EV car charging. So taking that AC line voltage and now having to convert it to DC for that particular solution. Your IT infrastructure, a line voltage lighting system, and any sort of HVAC devices that you have on the campus. The other thing that's associated with this is all of the equipment that's required for it. So if you look at all of these and the way that they're actually deployed, there's multiple transformers, rectifiers that need to be deployed for each of these solutions to transform that AC infrastructure to DC to be able to deliver those solutions. So if you look at just in total, the amount of equipment and also the amount of conversion that would typically be deployed in one of these solutions, we're looking at roughly around 20% of power that's wasted through those conversion losses as you go to each of the solutions. So you can look at it at an order of magnitude. If you would have let's say a smart building or some sort of a deployment that would be here, the more solutions that you have, the more inefficient that you're going to be at delivering that energy to those edge solutions. So how do we overcome some of the challenges that we have with the conversion loss from AC to DC? Is really looking at doing that conversion at the source. So we bring in our street power or AC voltage that comes into our facility. And then now we're doing that conversion once throughout that facility and then leveraging that highly efficient DC infrastructure throughout all of these solutions. So really being able to maximize my energy and maximize my efficiency throughout each of the solutions that we would be deploying throughout there, whether it be EV car charging, our IT infrastructure, our PoE lighting solution, shading, so on and so forth, really looking at creating that highly sustainable and highly efficient infrastructure, and then reducing the overall energy consumption that what typically would be needed in this type of a deployment. Another thing we've seen done and what is really on, let's say, the cutting edge is being able to bring in some of that on-site power generation, whether it be through wind turbines or through solar arrays, and really looking at maximizing some of that renewable energy, bringing that back into the system, and then also making that highly efficient, and then reducing the load on the actual grid. So if you look at it in terms of reduction in energy waste, really looking at 45%, maybe even greater during some of these solutions. We have a Penn 1 case study. Taking this approach, we reduced our energy footprint by 36% on a 44,000 square foot floor plate. So you can look at highly scalable, highly efficient, highly sustainable solutions for delivering these methods of energy delivery to these solutions.
Thank you, Ryan, for that deep dive. We are now going to show a short demo on the PoE analytics available from Catalyst Center.
In today's workplaces, where the utilization of the PoE has become widespread and also featuring a recent increase to 90 watts, a central management platform that offers clear information about the PoE devices, facilitates quick problem solving, and enables data-driven decision is absolutely essential. Cisco Catalyst Center, formerly known as DNS Center, serves as a comprehensive network platform overseeing the entire network, including headquarters and branches, wired and wireless, IT, OT, and then all from a single console. And as part of the assurance feature set, it also incorporates a specific functionality called PoE Analytics, providing detailed information about the PoE devices, power usage, operational status, device distributions, PoE insights, power load distributions, and power loss due to heat. As a result, this helps in the comprehensive monitoring of the PoE devices and the strategic planning of the PoE infrastructure, playing a crucial role in the efficient management of an intelligent or a smart building. What I'm going to demonstrate is the PoE Analytics dashboard on the Cisco Catalyst Center platform. Please note that this demo might not reflect the most recent release version of the platform. If you are using the latest release software, expect some changes in the appearance, including platform is currently undergoing a name change from a DNS Center to the Catalyst Center. When you first log into the platform, this is the main page. Then in the main menu, find Assurance and the PoE under the dashboard. Once you open it, here is how the PoE page will look like. The first two things you would want to do are select which site you want to look at. I am leaving it to global. And then choose the time range you want to look at. I'm leaving it to 24 hours. You will see a good insight here that tells you which platforms are supported by this feature and the minimum software versions recommended. You would also need to enable netconf on devices prior to discovering them in the platform. So when you scroll down, you will see 5 dashlets where 3 are specific to the PoE devices and the bottom two are specific to switches powering them. The first dashlet, called Operational State Distribution, shows you the total summary of all devices you have that are PoE capable. You can click on this and then look at the details. You're able to see what type of devices this is. This is a sensor, wirelessly connected. You're able to see where it is connected, which site it is at, and how much power it is drawing. You would also be able to see that I have one device that is faulty, where you can be able to go to that specific switch and then go to the support and be able to diagnose what's happening with that particular device. Another second tab that this dashlet has is you are able to look at the trends to see how your devices have been doing over the time that you selected. In this case, we have selected 24 hours. The second dashlet, called Power Distribution Devices, shows that how power is distributed among those power devices. You have multiple options that you can choose. In each selection, you are able to click on this bar and being able to look at the details and see what devices are and where they are and how much power is allocated to individual devices. The third dashlet, named PoE Insights, show you what type of PoE power it is distributed. When you click on the view details again here, you have multiple choices where you can see which type of PoE devices you have, the IEEE compliant, which is all my devices are, and you are able to click on the bar to be able to see which is unified APs that I have, and a little bit details on them from the inside perspective. The fourth dashlet, Load Distribution, will show you how many switches that you have and then how much power load they have it on them. By looking at the view details, you can click on them on the bar and then it will show you the details and you are able to scroll down and look at it. The last dashlet that I want to show is that you are able to see all of the power budgeting or the PoE power usage. You can see that I have total of 1.33 kilowatts, and I'm able to see how much power that my devices have consumed and what the remaining power. You are also able to see and click on the switch, and then it will take you to a device 360 where you can go and be able to view all the details of the devices connected to that particular switch. Hopefully from this, you are able to learn how you can utilize the Catalyst Center to manage your PoE needs. Thank you for watching.
Thank you all so much for joining us for today's episode of the web series. If you just joined us for the first time today, please make sure to check out our previous episodes on YouTube. If you enjoyed today's episode, make sure to also register for future episodes of the series. Our next episode is episode 4, where we'll be covering switching infrastructure. Thank you again for stopping by.